So 9.5 introduces what are called polar coordinates. And we just got done talking about parametric equations, but parametric equations still use the XY coordinate plane. It's just we have that third variable t as an additional parameter that gives us the direction of the graph. But now in the polar coordinate system, it's going to be different than the rectangular that we've been using, where we have our x and y values that represent the distance from the origin horizontally and vertically, like x comma y. Now the polar coordinate system is based on a circle, and instead of the origin, we have what is called the pole, or O. So that is where the origin is now. That's where everything comes from. And when we talk about points in the coordinate plane, they are in the form r comma theta. So r would be your radius, and theta would be your angle from the positive x-axis, which is called, the right here, the polar axis. So we start at the polar axis, or if we're referring it to our xy plane, our positive x-axis, and then we rotate an angle, and then we go out our units after the angle. Now remember that when we talk about angles, they are rotated counterclockwise from the positive x-axis, or in this case, the polar axis. So this is what an example of a point would be. You'd have your pole right here, which is 0, 0, your positive x-axis, which is now called the polar axis, and then we rotate theta degrees or radians, depending what we're given. Mostly we're going to be given radians. So we rotate theta radians, and then we extend our terminal side of the angle, our units, after we do that rotation. So if we look down here, there are some points in the coordinate plane graphed, like 3 comma pi over 6. So we rotated pi over 6, and then we went 1, 2, 3 units, and that's where our dot is. 4 comma 2 pi over 3. 2 pi over 3 radians, and then we go out 1, 2, 3, 4, and there's where our point would be. Now, we haven't talked about anything negative yet, because we know we can have negative angles. So if theta is negative, we rotate clockwise. And we've done that before when we first learned about radian and angle measures. We rotated clockwise for negative angle measures. So like this third point here, down we have 4 comma negative pi over 4. So we went pi over 4 clockwise, and then 1, 2, 3, 4 units out, and that would be this point. You may be wondering, well, what's this then? Negative 4 comma 3 pi over 4. That angle is positive. Yeah, but the r value is negative. So if r is negative, we flip over the pole. And I'll explain what that means, over the pole, or the origin. So for that one, negative 4 comma 3 pi over 4, we would rotate positive 3 pi over 4, which would put us here in quadrant number 2. But then instead of going 4 units in this direction, because it's negative 4, we go 4 units in the opposite direction. So it would land at the same spot. So we can extrapolate that and say, well, theoretically, you could have more than one point represent the same coordinate. You could have actually an infinite amount, because remember, you can keep going around the circle. But even if we keep our angle between negative 2 pi and positive 2 pi, we can have 4 different representations of that same point. So yeah, even for x, y, there's just one point for that location. X comma y, that's where it is. There's no other way to plot a point there. But we can have several different polar coordinates. Like I said, we could just always add 2 pi and keep going. We can also use negative values for r, and that will give us more points. So let's look at some examples here. So we're given one polar coordinate. We're going to plot it and then find 3 additional polar representations. So 2 comma 7 pi over 6. So we're going to rotate 7 pi over 6, which is right here, and then we're going to go out 2 units from the pole. So 1, 2. This is where that would be. So now we got to figure out additional points that give us that same ending location. So instead of going positive, we started from the polar axis and we went this way, 7 pi over 6. We could go in the other direction. We could have a negative angle. Well, if we have a negative angle, it's not going to be negative 7 pi over 6. It's going to be negative 5 pi over 6, because we're going 5 pi over 6 clockwise. So we're going to have 2 comma negative 5 pi over 6. So now we took care of the 2 points that have a positive r value. Now we have to find 2 points that use a negative r value. Well, 7 pi over 6, if we keep going, if we draw a line, do 7 pi over 6, you see how it lines up with positive pi over 6. So we know if we get an angle at positive pi over 6 and we have a negative r value, we're going to go backwards. So we can do negative 2 comma pi over 6, because that would go pi over 6 and then go backwards 2 units, 1, 2. It would land there. And then we could have negative 2 comma, instead of going pi over 6 units this way, we could go negative in this direction, and that would be negative 11 pi over 6. Now, a couple things to notice about our 4 coordinates. When the r values are both positive, if we look at the actual numbers here, 7 and 5, 7 plus 5 is 12, and 12 over 6 is 2. We do the same thing for the negative ones. We have 1 in front of this pi, plus 11 is 12. 12 over 6 is 2, and 2 pi is a full circle. So when I'm doing these problems, I like to just double check to make sure that this relationship always holds true. Then I got my correct coordinates. So if we look at letter B, 3 comma 2 pi over 3. So we're going to go 2 pi over 3, which is right here. And then I'm going to go out 3 units. 1, 2, 3. So my point is right there. I went from this direction, 2 pi over 3 units, and then 3 units out. So then our other points, 3 comma, well, instead of going 2 pi over 3 counterclockwise, I can go clockwise, and that would be negative 4 pi over 3. And now we can deal with the negative radius, and I would want to end up here. So -3, comma, well, how do I get there? We can go counterclockwise 5 pi over 3, or we can go counterclockwise in this direction, negative pi over 3. And I do my quick double check. 2 plus 4 is 6. 6 pi divided by 3 is 2 pi, or full circle. 5 plus 1. 5 plus 1 is 6. 6 pi over 3 is 2 pi, or full circle. So I'm confident in my coordinates here. All right, so now these are going to get a little bit more difficult, where we have negative angles or radiuses. So letter C, 1 comma negative 7 pi over 4. So I'm going to go 7 pi over 4 in the the clockwise direction. So if I were to do that, I would end up here at pi over 4. And then I'm going to go out 1 unit. So there's my point. Well, instead of going negative 7 pi over 4 clockwise, I could go pi over 4 counterclockwise. Okay, so then pi over 4 lines up with 5 pi over 4. So I could go negative 1 comma 5 pi over 4, because that would be rotating counterclockwise 5 pi over 4, and then going in the opposite direction of the pole 1 unit, and I would land right where the original point was. Then I could do negative 1 comma negative 3 pi over 4. You're going this direction 3 pi over 4. I land here, and then 1 unit in the opposite direction gives me that same point. Letter D, okay, negative 3 comma negative 4 pi over 3. So we're going to go negative 4 pi over 3, which would land us at 2 pi over 3, and then drawing our line. And then we're going to go 3 units, but not out towards this 2 pi over 3, but in the opposite direction. So 1, 2, 3. My point is actually going to be there, okay, because I had a negative angle and a negative radius. So then let's figure out our other points. Well, what if we kept the 3 negative and did 2 pi over 3? So I would rotate 2 pi over 3, and then instead of going out 3 forward, I'm going to go backwards 3 and land at that same point. Then we can deal with positive 3. So positive 3 and comma 5 pi over 3 would get us that point, because we see 5 pi over 3 right there. All right, then we can do 3 and then negative pi over 3, because we can go in this direction pi over 3 units and land there. Okay. All right, so I want you to try these 2 problems here, and then once you are done, unpause the video and see what we get. All right, so you can see that these are your answers. Check them, and if there's any mistakes, go ahead and fix them. Now, the last thing we're going to do is going to be talking about how to convert polar coordinates to rectangular coordinates. And it's the same way that we looked at vectors, and we went from the polar form of that vector to the component form of the vector. Remember, for vectors, it was the magnitude of u times the cosine of theta, comma, the magnitude of u, vector u, times the sine of theta. And we would find the magnitude of the vector by using the Pythagorean theorem. Same idea with these polar coordinates, that the x coordinate is going to be r times the cosine of theta, and the y-coordinate is going to be r times the sine of theta. So we would just use our calculator, unless it's on the unit circle, then we would use the unit circle values instead of our calculator. So example 2, convert the polar coordinate into rectangular coordinates by hand. So we have negative 4 comma 3 pi over 4. So the x-coordinate would be negative 4 times the cosine of 3 pi over 4, which would equal negative 4 times negative square root of 2 over 2, which would be positive 2 times the square root of 2. And then for the y-coordinate, negative 4 times the cosine of 3 pi over 4, which equals negative 4 times positive square root of 2 over 2. So that's going to leave us with a negative 2 times the square root of 2. So our x and y coordinate would be 2 times the square root of 2, comma, negative 2 times the square root of 2. So then letter B, we would have 2 times the square root of 3. So x would equal 2 times the square root of 3 times the cosine of pi over 6, which would be 2 times the square root of 3 times the square root of 3 over 2, which that will just equal 3. Then y equals 2 times the square root of 3 times the sine of pi over 6 equals 2 times the square root of 3 times positive 1/2, and that will just be the square root of 3. So my coordinates would be 3 comma the square root of 3. So we're going to do letter C and D with a calculator. Letter C is the unit circle one, but I just want to show and get practice using the calculator. So x would be 28 times the cosine of negative 2 pi over 3, and y would be 28 times the sine of negative 2 pi over 3. So at our calculators, and we're going to have to be in radian mode because those are pi radians. Okay, so 28 times the cosine of negative 2 pi, pi over 3. We get negative 14. And then if we change this cosine to sine, we get negative 24.25. So negative 14 and was it negative 24.25. Okay, then the last one, we have to use a calculator because 2.36 is a radian, decimal radian, not something on the unit circle. So negative x equals negative 4 times the cosine of 2.36, and y equals negative 4 times the sine of 2.36. So we're going to type both of those into our calculators. So negative 4 times the cosine of 2.36, and we get 2.84, and then we can go up and change this cosine to sine, and we get negative 2.82. So positive 2.84 and negative 2.82. So 2.84 comma negative 2.82. So converting them, again, is very easy, especially with our calculators. Just make sure you are in the correct mode. So that's our introduction to polar coordinates. Thanks for watching. Make sure to like the video and subscribe.